Our next speaker will be Nick Zentner from Central Washington University. He's a geologist and also teaches geology at Central Washington University since 1992. He received the 2011 Central Washington University Inspirational Faculty Award, 2012 Central Washington University Presidential Faculty Award. He's also produced a few YouTube videos, if you ever get on YouTube. Also, I had the pleasure of listening to Nick about a year ago in November at an irrigator meeting in Moses Lake, and he was very informative and very entertaining. So I'd like to introduce Nick Zentner.
Thanks very much. Hate to break into your lunch hour here. Lots of conversation to take place, but I'm very pleased to be here. I am from Central Washington University. I hope you can see these screens okay. We've got a lot of visuals for you here. I've got a friend who lives in town, in the Tri-Cities. He lives in Pasco, Tom Foster, and he's the plant manager for Twin City Foods. And so he's made sure that I have the best possible agricultural-related photographs to go along with the geology that I have for you, and so I'm excited to share that with you. So I hope you can see these screens okay. I hope the conference has been going well for you. I drove down from Ellensburg this morning. I'm different than the normal geology professor at a university. I like getting off campus. I'm not a researcher. My job is to be a bridge between the science world and the real world. And I do my best to communicate science. And I think more and more these days we need a lot of that. So I know your backgrounds in general. I grew up in Wisconsin, long line of dairy farmers. I'm the guy that left the farm, came out here once I found geology, so I've got that on my conscience. Dad's okay with that. But I made it a point to move to the Pacific Northwest 25 years ago because I knew quickly that this was the place to be. There's just absolutely outstanding geology in the Pacific Northwest. And many of you know that. Some from outside the region maybe don't know that. And there's an Ice Age tie. There's an Ice Age geology tie to damn near everybody in this room. And I'm hoping to make sure that you can see that connection. Okay, great. So let's see how we're doing here with images. I'm from the Kittitas Valley, so that's a valley 2 hours to the north of here, to the northwest. And there's plenty of agriculture happening in our valley. The town is Ellensburg. The university I teach at is Central Washington University, but there's lots of ranchers. There's plenty of cattle. There's a specialty hay crop, Timothy hay, which is exported primarily to Asia, so it's a little bit different maybe than your world. But the point is, those ranchers, those farmers in our little valley know the land like the back of their hand, and they've had a lot of time by themselves working and thinking and getting curious about lots of things that they've observed. And maybe that's you too. So when I started to do things with the public starting 10 years ago, and it started with just field trips and things like that, but it got into videos and public talks like this, I learned very quickly that there was a lot of thinking already about geology. And I'm guessing that's the case with many of you as well. So I'm not starting from scratch with most of you. You've already heard a few things. You've thought about a few things. And so maybe I can add to what you already know. There is Ice Age geology in the Kittitas Valley, but it's not the Ice Age floods. Most of you have heard of the Ice Age floods, I'm guessing, and we're going to talk a lot about that today. But those floods did not get into the Kittitas Valley. Instead, the Ice Age geology in my valley is a beautiful moraine, a ridge of glacial rocks that were bulldozed down from the Cascades. Essentially, there was a glacier that came down from Snoqualmie Pass right down I-90 and made it almost to Ellensburg. And there's also some beautiful outwash gravels, which are some river rocks being deposited off the front of the ice. But the Ice Age floods thing is not part of the valley. However, this guy Tom Foster, who I've already mentioned, but I'm going to mention him just a couple more times, and he likes to stay behind the scenes, so he'd probably have a stroke if he knew that I was talking about him right now. He, right out of high school, started working at Twin City Foods in Ellensburg. This is a food processing plant, frozen corn and peas. And he was sweeping the floor to start with and then started to work on the lines. And at a stage in his career, before moving on up, his job was to pick out the rocks that got mixed in with the carrots that were grown out on the Royal Slope and brought into Ellensburg for processing. And he started collecting these rocks, and he's an excellent cameraman, always has been. So he got curious about these incredible varieties of rocks that were brought in with these carrots during harvest. And he taught himself the Ice Age flood story. He still is an amateur geologist, but he and I have teamed up because he's got these beautiful camera skills and he's got the agricultural angle that I'm going to use today. So almost all the photographs you'll see today are Tom's. Tom Foster, unless otherwise noted. So we have the Kittitas Valley without the Ice Age flood story, but let's quickly go to the Ice Age floods in case you are a beginner to these concepts. So once upon a time, this is a story once upon a time. Over the last 2 million years, there was a hell of a lot of ice over Canada, and sometimes it crept down into Washington. And that wouldn't be much of a story. That happens all over the place. But meltwater off the front of that glacier in Montana got trapped behind the Bitterroot Range and in front of that melting ice sheet. And there was an ice dam, an ice plug that sat right over northern Idaho. Think Sand Point or Lake Pend Oreille or Coeur d'Alene. And a lake formed, Glacial Lake Missoula, freshwater, clear as a bell. And then finally there's enough water in that lake to break through the ice dam and come screaming over eastern Washington at up to 60 miles an hour and wreaking havoc, as they say on NFL Sundays. And so we have this channeled scablands where the landscape was completely transformed. And here's the punchline. It happened 100 times. 100 separate floods, 100 separate glacial lakes. So if you're brand new to this 5 minutes ago, and now I'm telling you it didn't happen just once, but 100 times, my goodness, what are we talking about? Hey, by the way, I've got good stuff for you. If I suck, after 5 minutes, go ahead and go back to the phones. But otherwise, let's lock in here. Okay, great. So these images, thank you. I'm sorry, that was too bold. Okay, great. So this is from a Geology 101 textbook, and we've got this color view, this 3D color view. Same story, Glacial Lake Missoula behind some ice, and then the ice gets breached, and we have this tremendous event. And by the way, all of this water, every drop of water came right over this convention center. So in other words, all this water had to reconcentrate and get into the Columbia River Gorge somehow, and it happened right here at the Tri-Cities at a place called Lulla Gap. So there's more than 800 feet of water above your chair multiple times during the Ice Age. Okay, let's try video here. This doesn't have sound, but this is going to get us flying into this ice sheet, especially in western Montana, and we're going to zoom in on what that ice sheet was going to look like to make that dam. So there's Glacial Lake Missoula. Can you see it? Now let's do a little cutaway here. And there's our plug of ice sitting in northern Idaho. And we've got some crevasses that are forming, some cracks. And in other words, we're going to eventually bust through this ice dam. This is a simulation of not only where the floodwaters hit, but the speed. So this is mathematically derived now. We're done with story time, and we're now crunching some numbers based on the landforms I'm about to show you. So let me explain before I put this in motion. The red is deep water, Glacial Lake Missoula. The blue is shallow water. You were at the red star. I don't know if you can find it, but that's Kennewick. And here we go. Ready? Let's break the ice dam up by Sand Point. 1 hour, 2 hour, 3 hours, 4 hours, 5 hours, 6 hours, 8 hours we can get the water to here from northern Idaho. And this is continuing to run as we drain Glacial Lake Missoula. And notice what's happening here at the Red Star. We're ponding the water again. So we had standing water in Montana, we released it, and then it's ponding again here because the Ice Age floodwater has to try to make it through Lulla Gap and to get to the Pacific Ocean. Okay, so to a geologist, this is a very exciting photograph. To many people, it's not that big a deal. To you guys, maybe it's super boring. There's no soil, there's no productivity here whatsoever. It's just a bunch of wasteland in your eyes perhaps. But this is a place where the soil's been stripped away, and more than that, the bedrock has been hauled away. This is channeled scablands. This is a place where the water lifted out a bunch of rock, bedrock, basalt lava rock, and hauled it away as well. This is up by Dry Falls. And there's other features that are just absolutely bizarre, and you don't see them all over the world. That's my point. This is a very rare place. So here's some giant current ripples next to the Columbia River. Can you see that boat in the Columbia River? This is south of Wenatchee, so that's the ripples are for scale. So we all know what ripples look like. This is in Ellensburg after a January thaw, and the Yakima River got a little high, and my son's out there, and the water was up to about his waist, and that little dirt path developed some ripples because the water was flowing. But that's normal, right? You go back to these giant current ripples, you go, my God, what kind of water, what kind of volumes, what kind of speed, what kind of depth are we talking about to create ripples that are, a football field from crest to crest and made out of rocks the size of me instead of little grains of sand or silt? And the bizarre observations continue. Huge canyons out in the middle of nowhere. This is the Palouse River Canyon. A coulee, an Ice Age flood coulee. Doesn't make any sense in its situation as you're driving to Pullman for a Cougar game. Or enormous boulders out in the middle of the desert. That in itself is interesting, but then you go, wait a minute. The bedrock here is brown lava rock, and this boulder is made out of white granite. What the hell's going on here? How did this thing get here? And there are hundreds of these erratics. The Ice Age floods brought them in and didn't roll them in. They were rafted in on icebergs. Where did the ice come from? That broken up ice dam in northern Idaho. So these are stories. And that's one teaching choice. You just tell the story and that's it. But I think it's important to show you the science behind the stories. So we're going to try to do that and weave in agriculture as much as we can. So some of the erratics have been moved. Some of the boulders have been moved by you guys. You've got to get going with your field there, and that's fine. This is over by Gorge, Washington. Some ice-rafted erratics have been pushed off to the side of a field. And there's coulees where people are farming, the floor of Moses Coulee, for instance, but not all the ag is coming within the flood paths, quite the contrary. Lots of dryland wheat is places where the Ice Age floods missed instead of hitting. So we want to kind of make a survey of the places around the Northwest. Here's a kind of a subtle photograph from Tom. He's like, even in this field, there's ripples. The Ice Age floods came through here. So some of these features knock you over the head, like something truly biblical took place, and other times it's more of a subtle thing. Maybe a bad choice there. Okay, the Drumheller Channels, very exotic place. Many of these places are exotic, is my point. All right, so it was just this fella Tom and I going out and hiking together and putting a few photos together, and then we got creative. We started doing video, and we started putting the videos on YouTube. And the internet's a powerful thing, and so now there's a much wider audience, not just us, of course, but there's other people who are getting this Ice Age flood story in the Pacific Northwest out of just the academic circles, where it really was firmly ensconced 25 years ago. And so some examples of that, a guy from National Geographic contacted Tom, said, hey, I got to go find some of these places. Let's do a new National Geographic article. So that's the guy in the red coat. So look for a National Geographic article on the Ice Age floods coming soon. And the other is a filming crew from the BBC in London. And they flew over and did an Ice Age flood show. So you get my point so far, right? You're living in a very unusual place geologically. You already knew that, perhaps, but I want to reinforce that with a bunch of these images. Okay, let's take a little tour then. Some of you are from each of these regions. Let's go up to the Waterville Plateau, up by Mansfield. Some classic glacial features up there. And notice that a big ice sheet, the Okanagan lobe, advanced over the border from Canada and sat right on that Waterville Plateau. Multiple times, not just once. So we've got to be careful now. These are beautiful boulders as well, but they are not ice-rafted erratics. These are erratics that were moved by the ice itself and dropped there. So think bulldozer instead of these floating ice bergs. That's an important distinction. So when you're up there growing some dryland wheat up there on the plateau, you're not exactly moving these rocks off to the side of your field every spring, which was the job for some of us for years. So you got to work with what you've got and do your best to throw that wheat around those glacial erratics. So again, these are glacial erratics, not ice-rafted erratics, the important distinction there. Look, they're growing rocks. That's great. Let's go over to Montana to that glacial Lake Missoula. And again, another portion of the ice sheet, the one that famously blocked the Clark Fork and made glacial Lake Missoula how many times? 100 separate times, not just once. So up above the University of Montana, many of you know, there are these scratches in the hillside, and those are the old high water marks of glacial Lake Missoula. Multiple lakes, multiple wave-cut notches into the west-facing side above the football stadium there, where Montana killed Central Washington earlier this fall. So you can hike up high and see the high water mark of glacial Lake Missoula. But if you look at the floor of glacial Lake Missoula, this is right off of I-90 driving towards Missoula, there are repetitive layers that tell us lake, lake drained, lake, lake drained, lake, lake. So this is one piece of evidence, in other words, that we had more than one lake. The alternating dark and light colored bands are telling us that story. If you farm in the Mission Valley, I understand you're farming seed potatoes and maybe a few other things, but the point for me is you're farming the bottom of a glacial lake. Those are soils that are directly from the floor of glacial Lake Missoula that, again, was not a lake for a long, long time. It was a lake for months, maybe years, and then drained quickly. You still don't have the timing of those different lake generations. And they've got rocks of their own that kind of drop to the bottom of the lake, and they've moved those rocks around. And you'll notice these rocks are different than our rocks. These are belt supergroup rocks, meaning these are Precambrian sedimentary rocks from western Montana that we can find in central Washington, just not a lot of them, because you've got to do this mental gymnastics to get this material here. Also on the floor of the old glacial Lake Missoula are spectacular giant current ripples. So I don't know how else you explain this, except you need water to move quickly to create these ripples. And that's a semi-truck there in the middle of the photo. So the scale of these are enormous. If you've got an excellent eye, you can see there's actually two different sets of ripples. In other words, they're not all parallel to each other. In the foreground, they're oriented a different way. So again, we've got multiple lakes through time, and we're draining a hell of a lot of water out of the state and getting it all the way to the ocean. You got to cross Washington, though, if you're going to drain glacial Lake Missoula. Good. All right. So up in a flying contraption, Tom over the shoulder of another guy, and going right down the Clark Fork River, and following the path of that floodwater. Okay, fine. So then if we get to Washington and we get that water out of the area, there are specific places where the Ice Age floods did their thing. Most famously at a place called Dry Falls that many of you know. So for a teacher, this is the best chance you've got to teach people about the Ice Age floods. I think easily this is the most convenient place for people to stop, see something weird, and understand that something bizarre happened. The scale of the story is so large, it's hard to go to one place and tell the whole story, but Dry Falls is as close as we've got for that. And you can fit Niagara Falls into just a small portion of this photograph. We don't need to go in that direction, but Dry Falls dwarfs current Niagara Falls. And I've given these talks through the years, and there was a guy in the audience one time from Spokane, a different Tom named Tom Tabbert, and he goes, "Hey, I like this stuff. I don't know much about it, but I like flying my little contraption. I got an ultralight, I got a trike, and I got some HD cameras on the wings. So how about I just do whatever? Tell me where to go. We'll just fly over the top of it." So we set that up. So here's Tom Tabbert flying over Dry Falls, and he's flying in the direction that the Ice Age flood waters were coming down from Grand Coulee Dam, essentially. And we're heading for the lip of the falls. Dramatic pause. Whee! So that was fun. Look at all that rock that's missing. I didn't get this when I first moved to the Northwest 25 years ago. Why the hell do we have all this rock missing? I get if soil can get stripped away by water, but why are you moving tons of bedrock? And the answer is, basalt is heavily fractured by nature. My favorite phrase is, the basalt was pre-cut, and it's ready to be hauled off by all of this water. So these coulees of eastern Washington were heavily influenced by this Ice Age flood erosion. We'll do more of that with Tom in a second. So here's the Grand Coulee, and coming down the lower Grand Coulee, we've got this enormous valley cut almost instantaneously, geologically. In other words, this is a very, very young valley, the Grand Coulee itself. And as we head south, some of you know where I am. If you're from outside the region, just bear with us here. I'll try not to do too much localized stuff. We're driving south towards the town of Soap Lake and approaching Quincy Basin, where there's a hell of a lot of agriculture. So here's up above Soap Lake. We can see that the soil is stripped bare. It's exposed basalt bedrock. But up ahead of us are circles, right? Green circles. Plenty of agriculture going on. The interesting thing geologically to note is that, oh, I love this map. Let's get ourselves turned around now. So now we're looking north. So you see where Soap Lake is. You see north of Soap Lake, there's a glacier. That's the Okanagan Lobe. And the blue dots is the diversion of the Columbia River. If you know the geography of Washington, you know today the Columbia River goes what? Grand Coulee Dam, and then Bridgeport, and Pateros, and Wenatchee, and Chelan's in there, you know, that idea. But during the Ice Age, multiple times we had this ice sitting on the Watervale Plateau and blocking the Columbia River drainage. So in other words, the Columbia River, for many times during the Ice Age, came right down Grand Coulee. The Columbia River, not the Ice Age floods, the Columbia River came over Dry Falls, came through Soap Lake, came through Moses Lake. Flowed right along the north base of the Saddle Mountains where Crab Creek is today. We got all sorts of evidence for this. I can't hold it, I got to say it before I forget it. The Grand Coulee Dam is a modern version of the Okanagan Lobe. In other words, the Grand Coulee Dam today, what does it do? It's diverting much of the water of the Columbia River and sending it due south towards the Tri-Cities. That's what the Okanagan Lobe was doing multiple times over the last 2 million years. So if you go to Soap Lake and head south and you drive towards Moses Lake, Soap Lake to Moses Lake, there are huge fields of boulders. I don't know if you've ever noticed them. And the boulders get smaller as you head south into the guts of Quincy Basin. There's a reason for this. These are flood boulders. We're back to the Ice Age flood story now. And the Ice Age floods, carrying all these rocks of different sizes, are coming down the Grand Coulee, and as the water enters the Quincy Basin, it slows. And as the water slows, it spreads out. And as the water spreads out, it drops its rocks. And so the slower the water, the tinier the particles. And by the time we're out to the middle of the Quincy Basin, it's fine material. So there's the Ephrata fan, which is this kind of gradation, a decrease in size of these rocks as you head towards the middle of Quincy Basin itself. So here's Tom's photos of all of his products going to his plant down here at the Tri-Cities. So the Quincy Basin is an important place for a couple of reasons. The main point is, story time was the Ice Age floods were powerful and moving quickly and going all the way to the Pacific Ocean. But wait a minute now. We've got places where that flood water stopped. And the Quincy Basin is one of those examples. Fast-moving water over Dry Falls, but the water stops as it fills the Quincy Basin, and then picks up speed again, and then stops again when it gets down here to the convention center. So I love this map. First of all, the water was almost certainly brown because it was picking up soil, it's picking up loess, picking up silt as it's going. And then I think of the Quincy Basin as a big bathtub that we are going to fill with Ice Age floodwater, and we're going to go too far. We're going to overflow that clawfoot bathtub, and we're going to have the water spill onto the kitchen floor. Do you have a bathtub in your kitchen? You don't. The bathroom. It's going to spill over onto the bathroom floor. That explains the geology within the basin, but it also explains places like this. This is, anybody recognize it? It's a beautiful shot. This is Potholes Coulee, or Ancient Lakes. Some of you know it, near Quincy, south of Wenatchee, north of Vantage. And what I'm trying to convey to you here is that there's massive Ice Age flood erosion by the water here because the water is leaving the rim of the bathtub and dropping to the bathroom floor. And there's erosion with that. So all along the margins of the Quincy Basin, we have Ice Age flood erosion. This is Frenchman Coulee. You could go to a rock show at the Gorge Amphitheater. That's another spillway where water's leaving the Ice Age bathtub and dropping down onto the bathroom floor. So Frenchman Coulee, you get there by Silica. These are all tangible, easy to find places that geologists go to all the time, and as we get the story out to more and more folks, more are hip to the story. Frenchman Coulee. Now we're at Vantage. This gives us a chance just quickly to talk about the bedrock itself. So this is a pre-Ice Age story that we'll do just a small portion of here. Many of you have heard that there are lava flows that make up the bedrock of eastern Washington. Layer after layer after layer of lava, Hawaiian-like lava called basalt. There's more than 2 miles of it beneath your chair. 2 miles of basalt vertically before we get down to the older rocks below the basalt. And the idea is we have these fissure-style eruptions like are happening today, this afternoon in Iceland, for instance. They're having this tremendous outpouring of basalt. There's also lava going into Kalapana, not Kalapana, but a town near Hilo on the big island of Hawaii. And the idea is we've got this scene. This is an animation showing some of this basaltic activity. So in other words, there was a more rugged landscape in Washington pre-volcanism, but 17 million years ago when these lavas started to come to the surface, the lava flows through time started to fill the valleys, and eventually there was so much lava that we truly buried a previously existing rugged topography. So I love this image of Washington. Our eyes are drawn to the flat eastern Washington, mostly because we're from there, most of us. But it's flat not because of the Ice Age floods, it's flat because of these lavas that buried a previously rugged topography in more than 2 miles of lava. So after each eruption, eastern Washington probably looks something like this. This is Hawaii today. Basalt, featureless, not much biology, certainly no canola, whatever. Great. That was my attempt to bond with you, by the way. All right. After the lavas were established, then we're developing frosting on this basalt cake, and the frosting is windblown silt. That's still happening today. Big dust storm, you've got silt-sized particles being blown over all of eastern Washington. And that's been going on for millennia, of course. So most of the soils of eastern Washington, and I'm not a soils guy, but I'll do my best to toss in a few things here. You know way more about soils than I do. But essentially there's tens of vertical feet of windblown silt sitting on top of that basalt. And if you look carefully in that loess, that windblown silt, there are plenty of paleosols, plenty of older soil horizons between flooding events, and then also we're downwind of the Cascades. We've got regular eruptions of every one of our 17 Cascade volcanoes, including the famous Mazama eruption from Crater Lake, but St Helens has erupted multiple times, Rainier has erupted many times, Adams, Baker, take your pick, Hood, doesn't matter. We've got all these tephras, all these volcanic ash layers that are also worked into this stack of fine-grained material sitting on top of the basalt. Again, I'm not a soil scientist. There's probably some in the room here. But the point is we've got this material sitting on top of the basalt, and depending on how much annual precipitation you have, depending on your elevation, depending on other things that I don't understand, you can develop a very fertile agricultural scene. So for my teaching, at the 100 level at least, we've got before the Ice Age floods, our basalt bedrock, and then these rolling Palouse-like hills across eastern Washington. Not just where they are now, but there was a thick mantle of this material, this windblown silt, across all of eastern Washington, from the Cascades essentially all the way over to the Rocky Mountains. And there are noticeable places today where that stuff's gone. And not only is the loess gone, but we've got intense erosion into the bedrock as well. I didn't really know what a coulee was when I moved out here. I'd heard of the Grand Coulee Dam, but I didn't have a visual for a coulee. This is what we want. A coulee is a box-shaped valley with an underfit river, or maybe no river, in the bottom of it. In other words, they are Ice Age flood erosion features, not formed by anything else. Like this. Yes, the Palouse River flows through this valley, but it was all cut by the Ice Age floods. The river didn't cut this thing. The river's like a poser that came in late in the game and just showed up to pose for pictures. But it's the Ice Age floods that did the heavy lifting to make this coulee. So to Palouse Falls, which is a state park and a beautiful place. Everybody loves a good waterfall, and we sent, Tom volunteered to go up there and fly over this as well. So as we've been getting him out there and getting Tom Foster's photographs, that's what people seem to like as they go to YouTube or other places to find these videos. So we'll fly with him for a second. Same idea, that we're flying over a flood path. The coulees are a direct result of the Ice Age water carving this landscape. Not a whole lot of agriculture in this photograph, but the agriculture's not that far away. Go over to Hooper and places like that, and you've got plenty of wheat. So what's up? Why don't we have ag in some places, but we have agriculture in other places? You know the answer to that in many cases, but let me help for those that don't. This is the Smyrna Bench, just on the north side of Saddle Mountains, up on a plateau where some organic peas are grown for Tom's operation at Twin City Foods. There was an Ice Age flood path going right down on the right side of the photograph where the Crab Creek drainage is. But this is up on the Ringgold Formation, lake beds that are older than the Ice Age and therefore not part of the Ice Age flood story. So there's one example of farming out of the flood paths. Here's another. Drumheller Channel, south of Moses Lake, north of Othello, one of my favorite places to hike. And just to remind you, you've already seen this, but Drumheller Channels is at the south, so it's one of those leaks out of the bathtub, but this is the south leak directly towards the Pasco Basin. And these are photos from the Drumheller Channels, which is not a good place to be farming for the most part. You throw some cattle in there maybe, get a little bit out of the land that way, but otherwise it's a wildlife preserve and a place that you can lose rock hammers if you're hiking on top of rock columns. But just along the western margin of the Drumheller Channel, suddenly you cross a threshold, a blue dotted line, and you're farming on the Royal Slope, and you've got orchards, and you've got hay, and you've got everything else. What's the difference? The soils were preserved there at the Frenchman Hills. The ringgold and some of the windblown silt is still there, and so the farming is good, with not good farming just in the background there, looking back into the Drumheller Channels. So from space, you can see the story the best. From NASA, you can see photographs that show these channels where the Ice Age floods hit. And all this pink are areas in eastern Washington that were not hit by the Ice Age floods. In other words, those rolling hills are preserved, and many of you live on those rolling hills, the Palouse. Here's Tom again, flying, this time straddling a boundary, showing us where some of the loess hills are still there, but also right in the middle of the frame, the floodwaters came through during the Ice Age and just swept the place clean. This is different, though, than Palouse River Canyon, for instance, because in this area, the Ice Age floods did not dig into the bedrock. They just skimmed over the surface, like I expected would be the case always. Look at that. So that triangular piece of property missed the flood erosion, but the floods hit everything else. And even some of the loess hills are streamlined. In other words, they were overtopped by some of the bigger floods, and there's a graceful tail downstream, like a salmon holding its position in a river. And so the farming can be done outside the Ice Age flood paths, as many of you know. Most of it dry land wheat. Dry land wheat, dry land wheat. Okay, getting close to the end here. Now we're close to home. In other words, close to where you're sitting right now. We're in the Pasco Basin. Remember now, this is another place where the water gets stopped. I mean, dead stopped. Why? There's Lulla Gap, which you can see at the bottom of this map. There's a narrow place for all the water to fit through. And there's so much water with many of these floods that the water can't get through it all at the same time. So it not only stops, but there's so much water, it starts to back up. It starts to creep up neighboring river valleys, up the lower Yakima River Valley, all the way to Missoula, north of the city of Yakima, up the Snake River, past Lewiston. Dead calm water creeping that far. What evidence do we have for that? That's coming in just a second. There's Lulla Gap. That's the bottleneck that's not letting all these waters get to the ocean at maximum velocity. If you go to selected places near Walla Walla, you can see this repetitive, chalky white story. Here's our evidence for multiple generations of Lake Lewis. In other words, here's another way to say there was more than one flood. Each of those layers is a separate Ice Age flood event. But here, we're talking about each of those layers being a Lake Lewis. So this is over by Walla Walla. This is a place right along Interstate 82 near Zilla. I just drove by it this morning. And it's important then to visualize that the Lake Lewis originally was brown, but as the lake water sat for maybe a week, with each passing day, the water got a little bit more clear, because we've got a snowstorm at the bottom of this lake. We've got all this silt dropping out of that lake and making one layer. Drain the water, another Ice Age flood, another lake, have the silt fall out the bottom, that's another layer. You get the idea? And there's even some volcanic ash layers in between these slack water sediments that helped us tie this story together. So there's a geologist named Bruce Bjornstad who also lives here in the Tri-Cities, and this is one of his most famous illustrations of the Tri-Cities, where you are. And the former high water mark of Lake Lewis, which we can reconstruct using the ice-rafted erratics, where they are perched up on Badger Mountain and Red Mountain, etc. And there's also spillways up above Lulla Gap that gives us the high water mark of that lake. But there's also evidence as obvious as this, right off of Interstate 82 in the middle of an orchard that you can see from the freeway, ice-rafted erratics. Yeah, people are farming right out here in the bottom of Lake Lewis, in those silts that drop to the bottom of Lake Lewis many times. Peas and carrots, I guess. This is Pasco right here in town, and yes, we're talking about more than 800 feet of standing water above this room each time we had a Lake Lewis. Here's a nice map showing that backing up of the water and all the sources of water coming down the Columbia, coming from Quincy Basin, coming from other places, coming down the Telford Crab Creek, coming down the Cheney Palouse track. And I also want you to notice that in the lower right of this map, we've got that water creeping all the way up the Snake. So if you follow the Snake River upstream from here, you'll find giant flood bars, and you'll also find this, one of my favorite spots in the Northwest. This is a state park, Hell's Gate State Park, just south of Lewiston, Idaho. We were just there this fall. And it's a gorgeous spot because there are 20 separate slack water sediment layers, like we were just looking at, by Zilla from the Missoula floods. But then below that, there's a very rocky flood deposit from one flood called the Bonneville flood that came from Utah. So not only are we talking about an Ice Age flood story coming from Montana, which is true for the most part, but there's this one rare, super big flood that came from Utah, spilled into the Snake, came down the Snake, came through Hell's Canyon, and also got to the Tri-Cities here. So there's a scabland topography, there's Ice Age flood erosion in the Snake River Plain, where Evel Knievel did his thing back when I was a teenager, and these gorgeous fields of these water-worn boulders. I mean, how can you walk through a field like this and just go, yeah, every place must be like this? It's incredibly unusual. Insert laugh track. Great. I want to say just a couple words about the Irrigation Project, and then we'll wrap it up. This is much closer to your heart than mine, because that water for many of you is your lifeblood, and I understand that. But I want to make that point one more time in case you didn't. It's one of my favorite points. During the Ice Age, the Columbia River was blocked by ice Today, much of the Columbia River is blocked by a concrete dam, and we're diverting the water in both cases. And as you pump that water from the Grand Coulee Dam project, and you pump that water up and out of the Columbia and into Banks Lake is a coulee. That's a coulee that was cut by the Ice Age floods. So this water is being stored and transported with the Columbia Irrigation Project using all of the work done by the Ice Age floods. It'd be a much harder project to engineer if you didn't have all of these features already there. So here's a map kind of showing we're diverting much of this water from Grand Coulee Dam directly down to the convention center here, and all of you guys doing some nice work in between with the Columbia Basin project. And some giant siphons and tunneling through the basalt, just amazing amounts of material being moved, transported, et cetera. So we convert, as you well know, these are classic photos, we convert something like the Pasco Basin from a dry area with sagebrush, and then we bring in the water due to this magical project with thousands of people working very, very hard, and the Pasco Basin is a very different place now. A couple final photographs. Once we get through Lulla Gap, we get into the Columbia River Gorge, and the Ice Age floods, it maybe hasn't dawned on you, the Ice Age floods came through the Columbia River Gorge as well. So there are ice rafted erratics all along both sides of the Columbia River Gorge heading towards Portland. And there's farming because the water slowed again. Even getting past Lulla Gap, the water slows down again because of a constriction at the Dalles. And so Lake Condon, not usually talked about, has silt deposits out the bottom of it. So there's plenty of ag between Lulla Gap and the Dalles. Maybe some of you are from there, Hermiston essentially. And here by the old Celilo Falls, there's ranchers living below the high water mark, but they're farming above the high water mark. This is on the south side of the river on the Oregon side. And even when you get down to Portland in the Vista House, you've got Ice Age flood water indicators that are right at that elevation. In other words, the water was deep enough to be right up to the Vista House, perched above the Columbia River Gorge. So if this appeals to you, and especially if this is brand new to some of you, there are a few resources I can pass along to you quickly. First of all, there's a couple of books that are outstanding. The title is On the Trail of the Ice Age Floods. On the Trail of the Ice Age Floods. The author is Bjornstad. And it's not a general book, it's a very specific book with specific places to stop your car, to hike, to fly if you've got the funds, to see all these Ice Age flood features. So that's highly recommended, On the Trail of the Ice Age Floods. There's also a group called the Ice Age Floods Institute, which is really formal sounding, but it's just a bunch of folks who get together and go out and learn this Ice Age flood stuff. There are local chapters throughout the Northwest, the Ice Age Floods Institute. There's a chapter in Ellensburg, which we run, and we take people out on field trips regularly. We also have evening lectures, but there's a chapter in Missoula, a chapter in Tri-Cities, there's a chapter up in Cheney, etc. There's Bruce's 2 books, one more time. And then for free, the best place to go right now or sometime tonight or whatever, hugefloods.com. This is my buddy Tom, the guy who provided all the photographs specifically for this talk. And he has done a beautiful job on weekends, on evenings, going out, taking photographs, gathering resources. And he's figured out Google and all this other stuff, so all this traffic goes to his site. I don't know how he does it, but he's got incredible view numbers. That's the way to work this now. How many page hits and all this stuff. He is doing more than anybody else to publicize this Ice Age flood science, and I'm happy to be involved with him with that. We've been making these videotapes. This is the first day of filming a few years ago. We had a little problem in the Drumheller channels, which people seem to like. There's no audio here, but I really am going to miss that hammer. Thanks for your attention. Appreciate it. Thank you.
We do have a few minutes, so is there any questions for Nick?
The question is, once you get the water, the Ice Age flood water, down the Columbia River Gorge and you get it to Portland, how much of the water shoots straight to the ocean and how much of the water spills down into the Willamette Valley? It's a good question. I don't have a number for you, but I can say that it's an elevation gain. So 100 floods, they're not all the same size. So if we talk about some of the bigger floods, we've got a maximum elevation that we can trace through the gorge. And then once we get to the Portland area, we've got this huge trough that is mostly sitting below the elevation of the high water. And so I'm imagining a quarter, if you'd like a number, a quarter of that water spilling to the south. But I didn't talk about the Willamette Valley. If you're from there, I apologize, but that's mainly because I don't know much about the Willamette Valley Ice Age flood geology, but there's ice-rafted erratics through there. There's definitely slack water sediments as well. So that is a part of the story, a portion of the water. Can't give you a specific number. Oh, good point. Yeah, they took our soil. Right. Those bastards down there got all of our soil. Excellent point. Excuse me if you're from Willamette Valley. Yes. So the question is, or the comment is, at Sprague. So we're on I-90 heading towards Spokane, and there are mounds instead of ripples. I know what you're speaking of. Those are called Mima mounds or Mima mounds, M-I-M-A mounds. Has anybody heard of those before? Mima mounds? Some of you have. There's even a Mima Mound State Park in Washington over by Olympia. And if you look on Google Earth with some LiDAR imagery, so you've got very detailed precision surface imagery, you can see all these little bumps that look like you're looking at the surface of a football, all these little mounds on the surface of a pigskin. You're waiting for an answer, and we don't have one. This is one of the biggest mysteries we still have. Mima mounds or Mima mounds, which are near the Spokane Airport, by Sprague, driving down towards Bend. If you're heading from Briggs Junction over to Redmond, they're every place. They're repetitive mounds, sometimes with stone circles surrounding them. There's grassy vegetation often on the mounds, and then surrounding it, it's more of a kind of an exposed lack of soil. There's been talk of seismic shaking creating those. There's talk of gophers. That's not a punchline. Gophers digging these things in irregular. There's talk of permafrost freezing and thawing to create that kind of a pattern. You know, the tops of columns and cracks up in the permafrost in the Arctic all have this kind of magical stop sign shaped pattern, including those mounds. It's a mystery. It's not tied to the Ice Age floods as far as we can tell, because they are found within flood paths and also out of flood paths. And at Sprague, you're right at the boundary between a flood path, and once you head west towards Moses Lake, you're up and out of the flood path there. So the mounds are great, not Ice Age floods for sure. It's a possibility. We can try towards the back. I don't know, you want to let her rip? Oh, it's like a talk show here.
How many years between the 100-year floods?
Good, thank you. You all heard the question. There is work to be done. And we're trying to get the level of precision with the dates of each soft sediment layer, like here at Zilla or the Tri-Cities. If we can get absolute ages for each of those deposits, each of those repetitive sediments at the bottom of these lakes, we can answer your question. We're not there yet. We're only using dates between the lake sediments. And so we have casual numbers placing us within the last 2 million years. But I was at a geology conference this fall up in Vancouver, BC, and it was very exciting because these young guys now, younger than 50, are using new techniques to get ages of the surface of boulders, cosmogenic radiation. In other words, they can measure how many years the surface of the boulder has been exposed to solar radiation using some isotopes and some other things. And they're getting dates going way earlier than previously sought. So if you know some of this Ice Age flood stuff, and you maybe have a brochure somewhere that says the Ice Age floods happened between 17,000 and 14,000 years ago, that's not the case anymore. We've got new dates that push us back 25,000 years ago, 50,000 years ago, in some cases older than 1 million years ago. But that's not what you're asking about. You want to know, is the lake around for, takes 100 years to make a glacial Lake Missoula, and then 48 hours to drain it, and then another 100 years to make glacial Lake Missoula, another 48 hours to drain it? That's about as close as I can get to an answer, but it's hard to back that up with precision, with dates. I'm happy to go all day. I don't know if the conveners want to do a couple more questions or not.
We have 5 minutes.
5 minutes, that's time for one long-winded question. Here we go.
You mentioned the paleosols, which I think you described as pre-flood loess,
Yeah.
and then covered and then didn't get affected by the floods, but then more loess came in post-flood.
Good.
And in some areas, those paleosols are close enough to the surface that they actually affect crop growth. And I've seen those where they're so dense and so compact that you actually have to drill through them rather than just poking your conventional soil probe through them. And the roots just can't get through that material. And
Yes.
is there any geological explanation for why they're so compact and dense?
I can't do much with the compact nature of the soils, but I can comment on probably a contradiction in the talk about the soils, and I already confessed it's the weakest part of the talk. My cartoons showing rolling hills of loess before the Ice Age floods, and then the floods came and took a bunch of the loess away, and that's the end of the story. I have changed. I need to change that diagram. I've learned a lot in the last 2 years about guys who've been working with the loess, and they're finding so many generations within the loess pile. So instead of all the loess being pre-floods, it's looking like each of the floods coming from Montana brings a new batch of silt down into central Washington, drain the water, have winds blow that silt back up onto the Palouse, have another glacial Lake Missoula, bring another batch of silt down, drain the water, dry everything out, blow that material back in. So it is a contradiction. I almost need to get rid of that cartoonish before the flood story, because it looks like if you drill into the Palouse, some of you dryland wheat guys over by Pullman, I think if you dig through your, 60 feet of Palouse silt before you get down to the bedrock, I think you would go through dozens of old soil horizons, which is indicating that we have a cyclicity to soil formation instead of everything being there before the floods did their thing. That's the best answer I got for you. Oh, one more. Hope it's a geology question this time. Oh,
I'd love that.
another question I can give a vague answer to. When are we going to have another Mount St. Helens eruption? Well, I'll tell you what. The good news is we've got geologists who are monitoring every one of our 17 volcanoes very, very carefully. So any changes in seismicity, in other words, earthquake activity, which indicates magma movement, will be known very quickly. And the best news I have is that almost always cone volcanoes around the world have weeks and weeks of small activity before they do something major. So this is unlike earthquakes that can harm hundreds of thousands of people at the snap of a finger, and we're clueless with predicting that. But we're closer to getting comfortable with the idea that we'll have small events leading up to a big event. There is no indication right now that St. Helens is building for a new event, because we all know in 1980, Mount St. Helens lost 1,300 feet of its elevation, and since 1980, between 80 and 86, and then between 2004 and 2008, there has been renewed dome growth within the volcano. Most, I think, would agree with me that St. Helens is going to want to rebuild itself completely before it has another ultimate eruption. So we're probably talking about another century of dome growth within St. Helens to get back to its former glory before the other event. Rainier's a different story, and Adams, and Hood. There's potential for an event tomorrow, but we can't predict these things. We're reacting instead of being proactive with these cones. That's why it's an exciting place, but it's also a potentially dangerous place. Yes, sir.
Is there an entrenched paleo channel associated with the outwash from this flood event that traces the Columbia Gorge? And is there a paleo delta out in the ocean that's still available
Good
to
question.
research?
Thank you.
And presumably sea level would have been lower
Yes, sir.
when the, so that's why I'm asking.
Wonderful. I promise this will be my last answer. So the question is, when the water finally, the Ice Age flood water does get to the ocean, did it just lose its velocity and just gently kiss the shore and that was that? No, this is a high energy event that had the power to cut a channel. So we have good bathymetric maps now offshore, off the mouth of the Columbia River, and there is a staggering underwater canyon that many believe, not all, many are thinking is a direct result of the Ice Age flood action. The bigger question is, are there deposits? We talk about soil leaving Washington and going to Oregon. Well, what about the soil that got flushed all the way to the ocean? Where's this huge stack of sediment? Is it under the water? And is it a more complete record of the Ice Age flood story? In other words, if we drill underwater off the shore, could we get a complete record of the Ice Age floods and fill in these gaps and get a much more detailed chronology? I think that's possible. I don't know of anybody planning to do that, and I'm not even sure those sediments are there. But the canyon is definitely there, and you're right. During many of these Ice Age floods, sea level was lower, so the Ice Age floods had farther to travel to get to the coast. In other words, there was a more of an exposed coastline. Washington was bigger during the Ice Age because sea level was lower, and therefore the beach was further offshore. Hey, I really appreciate all of your questions and your energy. It's been a pleasure to be here. Thank you very much.